Hey, hello there. So today's Leetcoding challenge question that's called single element in a sorted array. We have a sorted array of integers, and every element appears exactly twice except for one of the elements which only appear once. And we need to find that single number. So example 1, 1, 2, 3, 3, 4, 4, 8, 8. We get 2 there. That's the single element. The second example is 3, 3, 7, 7, 10, 11, 11. The number 10 is the only one that appears once. So if we use the bitwise exclusive OR operations, if we do exclusive OR between the same number, we get 0. And if we do exclusive OR between 0 and any other number, it will be that number. So 1 and 1 we get 0, 3 and 3 get 0, 4 4 get 0, 8 8 get 0, and 0 exclusive OR with 2 we get 2. So we get a linear time and constant space by using exclusive OR operations. The problem with that is it's not utilizing the property about sorted. It doesn't utilize the property that this array is sorted. And the note here gives us a hint because it's asking us to write an algorithm that's in log time. So that's when we have a sorted array, it's natural to think about binary search. So then, what kind of when we do a binary search, we need something that's telling us whether we should go to work on the left-hand side or the right-hand side. So what can give us that sense of direction? Let's look into one of the examples there. So if we put the index of the elements in this array, it's 0, 1, 2, 3, 4, 5, 6. Let's just throw in 2 more elements in there, 5 and 5. It's going to be 7 and 8. Because every element will appear exactly twice, and one of the element somewhere in the middle, potentially in the middle, gonna only appear once. You do see that there is this pattern before that single number. The two elements that the two replication of this same number is going to occupy the index in the form of 2n and 2n plus 1. That single number here is going to occupy a 2n location, because if it's in the beginning, it will be 0. If it's somewhere in the middle, all the numbers before it are going to be appear twice, so it's going to be occupying a location like 4 here. It's in the form of 2n, and after that it's 2n plus or minus 1 and 2n. So if you look at the 5 and 6, 7 and 8, that's indeed the case. 2n minus 1 and 2n. So if we randomly pick an index, we can look around to the number before us and the number after us, and just trying to figure out which case I'm actually belong to. So if this randomly picked middle index is 4, it's of a shape if in the form of a 2n, then we can check the 2n plus 1 to see whether this number is equal to that. If it's equal, then it's telling us we're in this first section here. If it's not equal, then it's telling us we can be in the second or third kind of pattern, in this array. So let's just annotate that the first 4 number of the first section or pattern, the single number it by itself occupies the second pattern. The 4 elements after that, it belongs to the third kind of pattern inside this array. So then we notice it's 1 1 1 1 2 3 3 3. It's a sorted array, and this gives us the direction. One little trick that I can think of is that if we randomly pick a number, if we do m exclusive OR with a single 1 bit, if the m is in the 2m form, by doing this, we are basically turning on the very last bit, then we become 2m plus 1. If the m is in the form of 2m plus 1, by doing exclusive OR with the 1 bit, we're effectively turning off the very last 1 bit, then we become the 2m form. So we just get this middle number by taking the average between low and high, then we do an exclusive OR with 1 bit. We can just only check for the first situation. So the very first time that we're violating this the pattern in the first we're violating the first pattern by checking the relationship between m and m exclusive of 1, then that number, that index is going to be the the second the single number there. So yeah, so that's pretty much the binary search, why binary search works. So what we're gonna have is the two boundaries. Low is 0 and high is the number of elements. -1, that's the index for the last element. And while we still haven't tightened the bound to be the single number there, what we can do is calculate this middle value, which is the average between the high and low. And then we just do the exclusive OR to grab that the counterpart for whatever that the m index really is. So we can just check whether this m number is equal to the this one. So if this is the case, meaning that we are still in the one pattern section in this array, we could safely rise up the lower bound to be m+1, because no matter this m number is 2n or 2n+1, we can always, the single number always has to be at least 1 after this m value, so we can safely to increment this lower bound to be m+1. Otherwise, we're just gonna set the high to be m. And after that, we can just return the numbers at this location. So that's pretty much the code. Let me run through examples. It seems to work. Let me throw one more example. And some special case, like just a single number in the beginning with some repetition afterwards, and some repetition and single number. Let's look at the numbers must be non-decreasing. Oh, I'm sorry. So let's change this 1 to be 3. Yeah, it matches the Leetcode judge code, so I think it should work. Yeah, it's accepted. So yeah, I guess it's important to realize there are basically 3 different patterns inside the array, and that pattern can give us the direction to conduct the binary search. So yeah, so that's the question for today.